Okay, so good afternoon, class. Today we're going to be solving inequalities using cut points. And the natural question is, well, what the heck does that mean? We've been solving equations up to this point. Equations always have equal signs in them, okay? An inequality has a less than or a greater than symbol, or it might have a less than or greater than. See this little greater than symbol? The name of this assignment I write up here, solving inequalities. And what the heck is an inequality? It has a less than, a greater than, or a less than or equal to, or a greater than or equal to, using cut points. There's several ways of solving, or a lot of different ways of solving inequalities. I'm going to show you a way that will solve pretty much any type of inequality. Okay? It doesn't matter if there's fractions in it, even if there's square roots or absolute values, it will work. Okay? Now, I'm going to pass around a sheet of paper with instructions for solving inequalities. I may as well just open it up right here. No, I don't want to do that. There. Let me see if I can make this a little bit bigger. Pause. Oh, we'll have fun. I'll just click right here. Okay, so I'm going to pass out the sheet of paper for those of you that are in here right now. If you're just watching this on the video, then this sequence of steps is located under Files for Spring 2024. There it is, cut point method for solving inequalities. So let me pass this out for those of you that are that are here. I have a paper copy to give you. And let's get back to the end of class the last time. We were reviewing interval notation. Like here on this number line, I have all the numbers between -7 and -5 shaded red. And y'all remember, y'all remember, I'm showing it right here. The closed dot means include, the open circle means not including. So the red numbers would be everything between -7 and -5, including -7, but not including -5. The black interval, all the numbers between 0 and 2, including both of those. This is called a closed interval because both of the circles are closed. This interval over here formally would be called half closed and half. Y'all want to guess? Open? Yeah. Okay. Over here we have all the numbers to the right of 6, including 6. And we put infinity symbols at the end so that we can continue doing the left endpoint, right endpoint. But for infinity symbols, you always put parentheses there. It wouldn't make sense to talk about including infinity any more than it would make sense to talk about including the arrow. Okay? If you're going to solve an inequality like that first one I showed right here, if you're going to solve one like this, if you're doing it correctly, you must draw a number line. Your strategy is going to be to find these cut points. And that's what I call the numbers on the number line that have an open or closed circle. So if we follow through the sequence of steps, here, you'll wind up with a number line drawn, with open and closed circles, and shaded intervals. Okay? If you just follow the steps correctly, you're going to get the right answer. Okay? You may not understand why you're getting the right answer, but you'll get the right answer. Okay? So I'm going to write down problem 1, and then we're going to start reading through the sequence of steps. I've printed out, let's see, I have some printed out steps here. entered over there. I have some over there on the table. Here, let me go. So, let me write this down. X squared minus 12x plus 20 is greater than 0. If you're thinking, well, how does this differ from the other stuff that we've been doing? Well, when we were solving quadratic equations, there was an equal sign. So if you notice the instructions, it doesn't say anything about using the cut point method or anything. It just says solve the following inequality. If it says solve, and if there's a less than or greater than, less than or equal to or greater than or equal to in it, then you're going to have to go through this sequence of steps. Another hint is it should also tell you to type your answer in interval notation. That was that stuff we were doing at the end of class with the number line the last time, okay? If you look at this sequence of steps, oops, where's my... There. If you look at the last step here, you see step 3, you're drawing a number line and labeling the cut points. Step 4 tells you how to shade. Step 5, at that point, you have a number line with open and closed circles and shaded. Step 5 is reviewing interval notation. Use a square bracket for closed circles. Use parentheses for open. Always use parentheses for infinity or negative infinity. Okay? But going through, the first thing we're going to do is find those cut points. And there's 2 types of cut points. Number 1 tells you how to find what's called the solution cut point. Number 2 tells you how to find the denominator cut points. Okay? It also tells you how to know whether you put an open circle or a closed circle on it. You won't always be doing step 2. If the problem doesn't have a denominator, you're not going to be doing step 2. On problem 1, did y'all write it down? Are there any fractions there? No. So it's going to be just, we'll skip step 2. So I'm going to switch over here, and we're going to start going through the sequence of steps. Okay. Again, the sequence of steps is posted on Canvas under Files, or I'm giving you, if you're in here right now, I'm giving you a sheet of paper with that sequence of steps. First step, replace the inequality symbol with an equal. This symbol right here is called the inequality. So replace the less than or greater than symbol with an equal sign and solve for x. Okay? These numbers we'll call solution cut points, and I'll abbreviate it SCP. So SCP. I'm finding the solution cut points, x squared minus 12x plus 20 equals 0. I'm finding what's called the solution cut points using step 1 of this cut point method. Well, do we know how to solve an equation like this? What kind of equation? Now we have an equation. Red is equation, the black is an inequality. Have we discussed how to solve an equation like this? Well, yeah. This is an x squared, so this is a quadratic equation. Factor it or use the quadratic formula. What do y'all think I'm going to do? Factor. Factor. Draw my 2 sets of parentheses. Well, for x squared, just x and x. That's a simple trinomial. Do y'all remember how to figure out the signs in here? The second sign is plus, so 2 of the first. So minus and minus. Okay, 1 times 20. 2 times 10. 4 times 5? I think I heard it. What pair of numbers are we going to use? The 2 and 10? Those are this is a simple trinomial because there's not that number in front of the x squared. So it's a little easier to figure out. Then once you've factored it, set each factor equal to 0. And we get x equals, is that a positive 2? And what's the other one? Positive 10, add 10 to both sides. So these numbers here are called solution cut points. We're going to be labeling them on a number line, just like over here when we had this number line. We should have a number line with numbers and open and closed circles and shaded stuff. Okay? Well, I'm wondering if y'all can read the note and figure out what am I saying we're going to use at these numbers. So we have 2 cut points, 2 and 10. If the problem contains a less than or equal to or a greater than or equal to, use a closed circle. If it doesn't, if it has strict less than or strict greater than, use an open circle. What are y'all thinking we're going to use here on these 2 numbers? Open circle. Okay? Why did we say open? Because there's not an equal sign. Remember, years ago, a student told me that she had a neat way for remembering whether you use open or close, and it had to do with what uses more ink. Okay. A closed circle uses more ink to write than an open circle. What would use more ink here? Writing just less than and greater than, or less than equal to and greater than or equal to? Well, you're writing that equal to, so this is going to use more ink, and that's how she remembered it. Okay? More ink, okay, to write it. So we've done the solution cut points. Next, we're going to find denominator cut points, but there are no denominators. So I'm going to make a note. There are no denominator cut points. Why? Because there are no fractions in the problem. You'll know when there's a fraction in the problem, and you have to do the second step. Now, step 3. When I say these steps, I'm referring to these cut points method here. Draw a number line and label the cut points. Don't label anything other than, you can go ahead and say negative infinity over on the left arrow and positive infinity on the right. It might be tempting to label 0, 1, 2, 3, but don't. Just put 2 marks, label 2 and 10. Make sure you're putting them in numerical order. 2 should certainly be to the left of 10, with open circles. Open circle, open circle. So how far have we gotten on our sequence of steps? Found the solution cut points. There are no denominator cut points. We've drawn the number line, labeled the cut points. Now step 4 tells you how to decide whether you should shade the interval or not. The way it's going to look is like what I did over here. Some of the intervals will be shaded, others will be crossed out. Okay? I'll try to justify why this method is working and what it's doing later. But right now I just want to go through, the sequence steps, convince you that this method actually works. So step 4, select a number in each interval and substitute it into the original inequality. So look at how we have 3 different intervals. That's what you call these little regions here on the number line, intervals. Select a number in each interval. Give me any number you want between negative infinity and positive 2. 0, that's a good one. Whenever I can use 0, that's the test point I use. Then we need a number between 2 and 10. Theoretically 2.78 would do it, but generally use small counting numbers if possible. Integers if you have to use a negative number. Okay, how about a 3? So I'm choosing the number 3, but any number between 2 and 10. 3, 4, 5, 6, 7, 8, 9 would work. And then finally a number between 10 and infinity. There's a lot of those. Which ones do y'all want to use? 11, okay. So I'm going to sort of make a little table here. Okay. So reading through step 4. Does everyone have the list of steps for the cut point method? If you're watching this video and you're thinking, no, I don't have that list, well, okay, it's under Files on Canvas. Select a number in each interval and substitute it into the original inequality. If you get a true statement, shade. If you get a false statement, cross it out. So let's substitute 0 in up here into the original problem. Right there. 0 squared would just be 0. Minus 12 times 0, what's that going to be? 0. And then we still have plus 20 is greater than 0. So 0 minus 0 plus 20, is that giving me a 20 on the left? Is this statement that I have true or false? 20 is greater than 0. True. Okay. Do y'all know what the word, so since it's true, that means we shade it. So I shade this in. Do y'all know what the word alternate means? Of course you do. You've heard the word alternate. If you had a true-false test and the answers alternated, if the first one was true, what would you guess the next one was? False. And then the next one? True. There's a way I can look at this and tell if it's going to alternate or not. And I'll tell y'all that way in a moment. Okay? Now, I want to go ahead and test the intervals. And you'll see this one's going to turn out false and this one's going to turn out true because it does alternate. So plug in a 3 into the original statement. That's a statement that has the greater than. 3 squared is 9 minus 12 times 3. Is that going to be a 36? And then plus 20 is greater than 0. 9 minus 36 plus 20. See, I'll picture that into your calculator. What's that going to give us? -7? -7 greater than 0. Is that a true statement? Is -7 bigger than 0? No, -7 smaller. Negatives are always smaller than 0. So I guessed correctly. It was false. Now plug an 11 in. 11 times 11, that's 121. Minus 12 times 11. Oh, what's that? 132? Plus 20 is greater than 0. You know what? I'm doing this by hand up here, but most of y'all are probably doing it with it. If we had this, plugging in 11 in for x, we'd have 11 squared minus 12 times 11 plus 20. What's that going to give me? A 9? Is that what y'all got if you punched it in?
Yes.
Because we'd have 141 minus 132. 9 greater than 0, is that true? Yeah, so shaded. Oh, something I didn't do. If it's false, cross it out. There. Okay. Now, is this similar to what we had at the end of class the last time? We have a number line with shaded regions. So write the shaded intervals, not the crossed out ones. The shaded intervals using interval notation. Okay? So, starting here, you always, with interval notation, you're always writing left to right. So when looking at this first shaded interval, we put parentheses because it's in infinity, it's negative infinity, comma, 2. What am I going to put on that 2? Open or close, bracket or parentheses? Parentheses for open, brackets for closed, parentheses. Then to indicate that it's on the same number line, we don't have two separate number lines, we go union, and that little symbol will be there for you to type in.
That's whenever, like, it's for the false statement, like, kind of breaking it up.
Huh? I can't hear.
The U, it's for, like, when you're breaking.
When you're separating the interval. So
Okay.
Here's the first shaded region, and here's the next one. Now, if you'd only had one shaded region, you wouldn't use the union symbol, okay? But all that's saying is it's on the same number line, okay? Let's see. What would this second shaded region be? Okay, I'm going to write a 10, and what do I put by the 10? Open or closed? Open, comma, infinity, open or closed, open. That's the thing I'll have to type in. Okay? This is the only time I'm going to test all three intervals. I'm going to tell y'all in a moment how you can look and decide, do I need to test them or does it alternate? I've found that students have a better chance of messing up testing than just saying, okay, do it one time and then alternates. Okay? It's not often, it's theoretically possible, but it's not often that you'll see false, false right beside each other. Okay? They almost all alternate. So let me type in this answer. Parentheses. Okay, so parentheses, oops, I thought I did. Parentheses, negative infinity, there it is. Don't hit any spaces. Comma, 2, close parentheses, union. You would never be using this intersection thing. Okay, you use the one that looks like a U, not the N. Parentheses, 10, comma, infinity. Okay. Any questions there? Okay. If you're wondering, why is this working? What is it doing? Well, if you stop and think, long and hard enough, you want to know when this stuff is greater than 0. Well, find where it equals 0. That's what we did here and here. Where does it equal 0? Everywhere else, it needs to either be greater than or less than 0. And that's what you're doing. Okay, over here, it's greater than 0. In the middle, between 2 and 10, it's less than 0. To the right of 10, it's greater than 0. Find where it equals. Everywhere else, it's either less than 0 or greater than 0. Test an interval to find out. How do we know, or how can I look at these and say, oh, it's going to alternate? Well, if you have nothing but linear equations, if no factoring is required, it alternates. Well, in this one, did we have to factor? Say, yeah, we factored. Where? Right here is where we factored. Okay? If you're factoring it, as long as there's no repeated factors, then it alternates. I think I'm going to word it this way. If there are repeated factors, it might not alternate. In which case, then you need to do what I did and check all three intervals, or all of the intervals. Okay? But what do I mean by repeated factors? If when you're doing this part right up here, the factoring, if you get the same thing in both sets of parentheses, did I get the same thing in both sets of parentheses? Say no. So I knew it alternates. Okay? If you're getting the same thing in both sets, that's when it might not alternate. Okay? But we got x minus 2 and x minus 10. If we've got an x minus 2 and x minus 2, okay, check every interval. Okay? If you have the same thing in both sets of parentheses when you're factoring. Now, if there was no factoring required, then okay, it's going to alternate definitely. Let's try another one of these. Problem number 3. That's a colleague of mine said years ago, wow, this will solve any type of inequality. Once we do number 5, I'll tell y'all the method that I learned when I was a student. This is the method the teacher showed us, but it wasn't this cut point stuff. So it says, solve the quadratic inequality, write the solution in interval notation. At no time will it ever say anything about use cut points. Okay? You just got to know that. Let me come over here. Okay, so does everyone have a copy of the steps? They're over there on that table. And I have some here. I don't think I've seen anyone enter through over here. Okay? And they're all also posted under files on Canvas. Okay. Will we have any denominator cut points?
No.
No, there's no denominator. The next one, the one after this one, I'll do one for this denominator. So the first step, replace the inequality with an equal sign. I'm finding what's called the solution cut. X times x minus 1 equals 12. Now, in order to solve this, you might think, well, wait, it's already factored over here. Yeah, but no, you can't really use that because there's not a 0 over here. You're going to have to distribute the x squared minus x, and then I'll go ahead and move the 12 over. This is what we were doing when we started solving quadratic equations by factoring. Well, let's see. Draw your two sets of parentheses. Let's see. How's this going to factor? Oh, x and x. 1 times 12, 2 times 6, or 3 times 4? 3 times 4. I should have asked this already, but I forgot. Second sign is minus, so what signs do we have in here? Different signs, a plus and a minus. How should I arrange them to get a negative 1x as the middle term?
Negative 4 plus.
Did y'all hear that? A negative 4 and a plus 3? If you FOILed that out, you'd have x squared, then a minus 4x and a plus 3x. The minus 4x plus 3x combines to give the minus x, or minus 1x. And then minus 12. Okay, so we factored it. Set each factor to 0. Hey, wait, are these going to alternate?
Yes.
Yes. If we've gotten the same thing in both sets of parentheses, then it might not alternate. You need to check all of it. That's what I was trying to say down here. Did y'all understand what I was? This is actually a pretty significant statement here, so you don't have to be checking every interval. Okay? By the way, which number did y'all think was easiest to plug in? 0? That's usually what I'll do, is plug in 0 once I draw the number line. Oh, heck, I haven't even finished finding the solution cut points. This is a S, not a 5. Ooh, okay, you can see it there. Solution cut point, that's S. So to solve x plus 3 for 0, we just move the 3 over or subtract 3. Would y'all get a negative 3? What about the other solution cut point? Would y'all add 4 to both sides? If you have these steps memorized, great. But if you don't, and I'm assuming you don't, you want to be looking at the sequence of steps. I mean, remember one time a student just, how do you do why? No, not why. How do you know to do that? I was like, read the steps. Just like, how do I know what the symbol's going to be, open or closed circle? For the solution cut points, reading the note, and y'all tell me what am I going to put there, open or closed circles at those numbers?
Oh, closed.
Closed, because unless I miscopied it, I have an equal sign there. You look at the original symbol, so it's going to be a closed circle because there's an equal sign on it. If there hadn't been an equal sign on it, it'd be open circle like number 3, like the first one we did, number 1. Now we've already said since there's no denominators, there's no denominator cut points. So we'll say no denominator cut points. So that means skip step 2. Sometimes I label these step 1, step 2, step 3, but if you're a viewing example type of person, it just sort of depends. Sometimes they find the solution cut points first. Other times you find the denominator cut points. It doesn't really matter what you do first. Well, in this one, there are no denominator cut points, okay? So now we're up to step 3. Draw a number line and label those cut points. Okay, here it is. Sometimes students laugh at me or think, what sort of idiot, when I say make sure you put those numbers in numerical order. We have negative 3 and positive 4. Which number is going to go here on the left? The negative. Positive 4. Now what did we say we have? A closed circle? You know what? I should have written this little note. No repeated factor, so it's going to alternate. I think plugging 0 in is usually the easiest number to test, but you got to know, where does 0 lie? Which interval am I testing? Okay, it's the middle one. 0 is between negative 3 and positive 4. I'm testing 0. Remember one semester a student said, well, wait a minute. 0 keeps moving around. Over here it was on the first interval. Now it's the second interval. You've got to know these cut points, okay? In general, here's a deep statement, not really. 0 is always between a negative number and a positive number. 0 is never between 2 positive numbers. Is it ever between 2 negative numbers? No, 0 is always between a negative and a positive. That's why 0 is over here on problem 1. Zero's not really moving around, okay? It's always between negative and positive. So I'm going to test 0 by plugging it into the original problem. In place of the x, I'd have a 0. Then 0 minus 1 is less than or equal to 12. Oops, where's mine? Let me move this cursor. Oh. Well, 0 minus 1 is negative 1. Anything times 0 is what? What are we getting on the left? 0. So is this statement true? 0 is less than or equal to 12. It's sure not equal to, but is it less than? Yeah. So what are we saying this statement is? True or false? True. So that means shade this interval. What about the other two intervals? If it's going to alternate, then right here, do I shade this one or cross it out? What about over here? Am I going to have to type in one of those little union symbols here? No. Okay. So the answer looks like this. I only have one interval. Always, always, always go left to right. If you go 4, negative 3, it's going to be wrong. You go open or close circles at the numbers. Close because, excuse me, there's open circles. Brackets or parentheses. What are we going to write? Bracket. Bracket, negative 3, 4, bracket. What we did was we found where the left statement equals 12. Everywhere else, it's either going to be less than 12 or bigger than 12. Okay. So let me type that in. For the bracket, the square bracket, I'm just using the bracket off of the keyboard. Right there. Bracket, negative 3, 4, bracket. Colleague said a long time ago, this will solve any type of inequality. Even if you don't understand why it's working, but as you do more, hopefully just keep in mind, you're fighting for it equals 12, everywhere else it's less than or greater than, and that's what you're doing with the testing. I'm going to do number 4, but I want to do 5 first. I think 5 is a better first example with fractions. So I'm going to move on over. Are we going to have any denominator cut points here? Yeah. It says solve the inequality, and the instructions also mention interval notation, and there's an inequality symbol. If there's a less than or greater than, that's when you do use the cut point method. 4x over x plus 2 is less than or equal to 5. 4 over x plus 2 is less than or equal to 5. Well, first thing I'll do is find the solution cut points. So I'm going to write down 4x over x plus 2 equals 5. I've rewritten it from an inequality to an equation. We know how to solve a inequality. I think an equation. I think I'm going to write it as over 1. And what am I about to do? Cross multiply. So I'd have 5x plus 10 equals 4x. Or if you want to go 4x equals 5x plus 10, however you want to go, is fine with me. I mean, whichever way you write it is correct. There's no wrong way. Now, do we have a quadratic equation? Are we going to have to factor on this one? Are there any x squares? No. So, will it alternate? Absolutely. If there's no factoring required, it alternates. Okay. So, here's how I'm going to solve this. I want to get all the x's together. I'm just isolating the x. I think I'm going to use my arrows to indicate that I'm subtracting 4x from both sides. And what am I doing with the 10? Is that subtracting 5x minus 4x. That would just give me an x on the left. I want x equals a number. What number am I going to have on the right-hand side? Is it negative 10? Y'all follow what I do with these arrows? I just think that's cleaner than minus 4x, minus 10, minus 10. Y'all agree with x equals negative 10? Look up here, open or close circle. Maybe a closed circle. So I'll make a note of that. And I have room right here to find the denominator cut point. See, this is the first time we've done step 2. At least the first time we've called it denominators cut points. But y'all have actually found these denominator cut points before. I remember when it was saying, here's a rational equation, what numbers can't be solutions? We were saying the denominator of a fraction can never be 0. So that's all you do here is you take the denominator, or denominators if there's more than one, say it can't be 0, and isolate the x. So here I am finding the denominator cut point. X plus 2 cannot be 0. Could y'all isolate x pretty easily? What would I do? Subtract 2. So we have x equals negative 2. Y'all remember when we had fractions and we'd say denominator can't be 0? Those would be the numbers that couldn't possibly be solutions to the rational equation. Now, I'm not going to say anything. I'm wondering if y'all can read the note and tell me whether it be an open circle or a closed circle at that negative 2. No. Read the note. There's a number 2 note. Always label denominator cut points with an open circle. You don't have any, just always open. If there's a denominator and you find a denominator cut point, it's always going to be open circle. Why? Well, open circles mean not including. So we're not including negative 2 as an answer. If we put negative 2 in here and here, 4 times negative 2 is negative 8. Okay, but what about the bottom? Negative 2 plus 2 is 0. Do you ever want a denominator of 0 for a fraction? No. So for the denominator cut points, always, always, always have an open circle there. Okay? It's for the solution cut points that you have to look at the symbol to decide. Okay? If you're a view and example kind of person, they're not calling these things solution cut points and denominator cut points. They're not even calling them cut points. It's just these numbers. Okay? I think having some sort of way of referring to these is important. It's the denominator cut points that are always open circles. The solution cut points, that's when you look at the symbol and decide between open and closed circle. Now, step 3, draw a number line. Hey, was there any sort of factoring anywhere in this problem? No, so it's definitely going to alternate. Draw a number line. Label my negative infinity and my positive infinity. Now, here's where it gets tricky. You're only labeling the cut points. Negative 10 and negative 2. Make sure you put these in numerical order. Which number, negative 10 or negative 2, would be closer to negative infinity? Negative 10. So the negative 10 goes here with a closed circle, and the negative 2 goes here with an open circle. As long as 0 isn't a cut point, you can test with that. If there's a rare time when 0 is a cut point, then I'd probably use 1. But for this one, could I test 0? And if so, where does 0 lie? The first interval, the second, or the third? The third. 0 is always between a negative and a positive. So this is where 0 is. One time I remember a student saying, I'm giving the impression that where that 0 is really important. And yes, it is. Okay? Knowing that test answers on a test with multiple choice and alternate is worthless if you don't know that the first, like here, we know this one. Okay, if it's true, then false, true. If it's false, then true, false. But you still got to know where that test point is. So I'm going to take a 0 and plug it into the original problem. On top, we have 4 times 0. On the bottom, 0 plus 2 is less than or equal to 5. 0 is less than or equal to 5. What do y'all say? Is that going to be true or false? Is that true? 0 is less than 5? So true. So that means I shade this one. What do the rest of them look like? What am I going to do here? X. And right here? Shade. So now, how would we write this answer in interval notation? Go from left to right. Don't start with the negative 10. Don't start with the negative 2. You're looking at the shaded intervals from left to right. Okay, so start off. Negative infinity. Notice how I put parentheses there. Comma. Negative 10. What am I going to put? Parentheses or bracket? Do I have to type in one of those little union symbols that looks like a U? Yes. Because we have more than one interval. So now I'm using this one here. Parentheses or bracket. Parentheses, negative 2, comma, infinity. What was this? Parentheses. So if you're sitting there thinking, oh wow, this is pretty bad, then if you want a different method, I'll tell you the method that I saw the first time I ever did this. The teacher had a method called think about it. You sat there and looked at the problem and thought about it until you came up with this answer. The first time I ever saw this sequence of steps, and it's not my sequence of steps. I mean, you're not going to find it written like this in a book, but it's just this my version of taking all the book stuff and writing it out, giving names. I love names. Imagine if the quadratic formula didn't have a name. What would you call it? Well, it's this thing, negative b plus minus. I like this. If I say cut points, hopefully by the time this is all over, it's going to mean something to you. Oh, yeah, that's where we have the less than, greater than, and we draw an underline and a shade. But I'll tell you, thinking about it, that was not an easy method. And I guess when we left the old building, they're all tearing up there at the intersection of Baldwin and Ayers, the old Memorial Classroom building. That was when I finally threw away all of my old math notes. And I used to still get those out and look at it just to convince myself, yeah, we really were just thinking about it, okay? And years later, it dawned on me what that meant. The teacher didn't really know how to do them. Oh, wow. Huh. Did I type that incorrectly? Yes. Mm-hmm. Let's go back to number 4. Okay. Are there going to be any denominator cut points here? Yeah. Let's see. Negative 4 over x minus 1 is greater than negative 1. How do we know there's going to be a denominator cut point? Well, we have a fraction, right? Okay, so let's start off by finding the solution cut point. We'll replace that greater than with an equal sign. Sometimes students try to come up with all these rules to avoid having to test the interval. They come up with, oh, if it's less than, it's always, well, something like here, the less than was false, true, false. But over here, the less than equal to was it still false, true, false? No. There's no way around testing one of these intervals. Okay? If you think you've come up with a way to get around it, no, you haven't. Okay? Solution. So I have negative 4 over x minus 1 equals negative 1. I'm going to go ahead and write that negative 1 is negative 1 over 1 and cross multiply. I'll have a negative x plus 1 equals, is that a negative 4? Oh gosh. Oh, by the way, remember, sometimes students will say they want to go negative 1 over negative 1. No. This sign goes on the top number. Okay? Don't put negative in negative, because if you put negative in negative, that would be a positive one. So let's see. This is just a linear equation. How do we want to isolate the x? Well, if we want as few negatives as possible when we're working through this, here's what I would do. I wouldn't move the 1 over. I would move the x over and then add 4. Those little arrows, that means add x to both sides or just move it and change the sign. Why did I do that? Because I want x equals a number. I don't want negative x equals a number. And then here, this arrow, what am I saying to do with this minus 4? I'm going to add it. Would it be a 5? Are y'all caught up? Everyone over in the peanut gallery? I can see just a little bitty snipper of it there, one person. Any questions? Y'all following what I'm doing? Open a closed circle here. Number 4. You gotta look at the symbols. What is it going to be? Open. Okay? So I'll make a note of that. Open circle. I like the format I used a while ago, setting it up. I'll draw a vertical bar and find the denominator cut point right here. Find the denominator cut point. Take your denominator, say it can't equal 0. X minus 1 cannot equal 0. So isolate the x. X can't be 1. Let's see what I did there. How I solved that. The denominator can't be 0. So to isolate the x, I'm adding 1 to both sides. So x can't be 1. Open or close circle for the denominator cut point. Always open at the denominator cut points. Okay. For the solution cut points, you look up here. For the denominator cut points, they're just always open. I'm here sitting imagining what it would be like with this without me saying this terminology. What would I say? Well, for these numbers over here, where we put an equals, you look at this symbol. And for these over here, where we're taking the denominator and saying it can't be 0, it's always open. I like these names. Absolutely critical that we get these numbers labeled in numerical order. So I'm labeling a 5 and a 1. Which one goes on the left? 1 and 5. They both have open circles. Oh, and look, 0's moving around. I'm going to test the interval that has 0. Where is 0? In the first interval, the second, or the third? This first one, 0 is always between a positive and a negative. It's never between two positive numbers. So at the end of the semester, when someone says, hey, you were in one of those Mr. Precella's algebra class all semester long, what did you learn? You can tell them. I know how to locate 0 on a number line. And you're laughing. Hopefully you're getting that as a joke. Okay? That's what you can do. You can locate 0 on a number line. They'd probably be like, well, could you not find 0 before that? You took a 6-hour, that's what you're doing. You're taking a 6-hour algebra class, okay? And it took a 6-hour algebra class for you to locate 0 on a number line. But anyway, so it's this interval. If I plug in a 0 here for x, on the top I have a -4. On the bottom, 0 minus 1. Is that just going to be a -1? It's greater than -1. So we have -4 divided by -1. What's -4 divided by -1? 4. So it's my statement. True or false? 4 is greater than -1. That's true, isn't it? So, shade. What else do we do? This interval, do I shade it? No. What about this one? Okay. So now write the interval notation. You've got to start with the negative infinity. Don't start with the 1. You go left to right, looking at the shaded intervals, not the crossed out. So it's going to be parentheses, negative infinity, comma 1, parentheses, then a union. What am I going to put there? Parentheses, 5, comma, infinity, parentheses. Negative infinity, comma 1, And if you don't like that, well, think about it. Just think about it. End of the semester, back then we did these little on paper, this is back way up, I wasn't born, but we did these little paper surveys that we had to do at the end of the semester, and I remember it asked one of the questions, I hope they don't do that anymore. Is there any pet peeve? Because I'm sure then y'all be like, his voice, that annoying voice of his. But it asks, does the instructor have any annoying pet peeves? And me and Tim, we were both in the class, both wrote, think about it. I am sure she knew who did it. You know, okay. They both said it, okay. But, let's do another one with fractions. Oh, gosh. Number 6. Will there be denominator cut points on this one? Yeah. Let me write it down. Number 6. Z over Z minus 10 is greater than or equal to, greater than or equal to 2z. Since you don't type in any variables, it might be, if you wanted to write an x in place of those z's, that's fine. Just make sure you don't turn a z into a 2 before it's all over. I'm hoping that doesn't look like greater than or equal to 22. Start off finding our solution cut points. Move it like this. Trying to do it very low tech. So I'm not having to flip screens or anything there. Okay, so for a solution cut point, replace the less than or equal, the greater than or equal to with just an equal sign. So we have z over z minus 10 equals 2z. I'll write that as over 1. And cross multiply. 2z times z, that's going to be 2z squared. 2z minus 2z times a negative 10, is that going to be a minus 20z equals, just z times 1 is z. How does this one differ from the last two we did? Well, if you look at them long enough and hard enough, I think you'll figure out there's a square on it. This is not a linear equation. It's a quadratic. So we have to get a 0 on one side and either factor or use the quadratic formula. As a general rule, don't use the quadratic formula on these. All of these factor. I'm going to subtract z. Okay? That little arrow there means subtract z. And I wanted to do this problem because it's going to show some factoring that we haven't done yet this semester. Or at least I haven't done it up here in front of the class, and neither has my brother. Okay? Negative 20z minus 1z. Is that going to be a negative 21z? Okay. Now, since there's a square here, that means it's a quadratic equation, so you need to factor it or use the quadratic formula. Don't use the quadratic formula, just factor it. I want to point out how this one differs. Like over here we had quadratic equations, but notice there was that constant term here. So that's when you draw the two parentheses. So for this semester, this is the first time it's popped up. I haven't shown you how to factor something when there's not that constant term. It's actually easier than drawing the two parentheses like this. It's called factoring out a variable. There's a z in each of these terms. See if y'all remember doing this at some time in your math class live. If we took a z out of each one of these, this isn't reverse FOIL, this is sort of reverse distribute. What would have to be in here if we factored a z out of each of those? It would be a 2z, then a minus what? 21. Okay? So this is the easy type of factoring, where you don't have to draw the two sets of parentheses or anything. If there's not a constant term in there with it, just factor the variable out of each term. Factor a z out, but there's one thing that's tricky about this. You've got to set both of these things to 0. Even this thing that just says z, you've got to set it equal to 0. There's one of your cut points. It's very tempting at times students forget to set that z. If there's not some numbers with it, they think, oh, that doesn't count. Yeah, it does. Set the z to 0, then set the 2z minus 21 to 0. See, the blue one here, the 2z minus 21, that's when you got to isolate the z. Over here, the z is already isolated. So how would I solve 2z minus 21 is 0? I would add 21. So we have 2z equals 21. That is not 22 equals 21, okay? There is no 22 in this problem. It looks it. And then one other thing, what do I have to do now to get the z by itself? Divide both sides by 2. So we have 2 solution cut points. Remember we mentioned if you have a quadratic equation, you should expect 2 answers. So we have 0 and 21 over 2. Or we can have an open or closed circle. So look at the symbol. If there's an equal to, closed symbol. A closed circle. Okay? For the solution cut points, you've got to look at the symbol. For the denominator cut points, what do we always have for denominator cut points? We say denominator can't be 0. Yeah. So the denominator cut points are always open. So this one's pretty easy to find, that denominator cut point. You say denominator can't be 0, so z can't equal what? 10. So draw a number line. You're going to label 3 cut points. 3, 0 is a cut point. 21 over 2 is a cut point. And 10 is a cut point. Drawing my number line. Now I'm going to label 3 marks. I'm also labeling negative infinity and infinity. Now there's 3 of these things. 0, 21 over 2, and 10. Oh gosh. Oops. Make sure this. 21 over 2 is 10.5. You might want to do that in order to figure out where do they go. What's the first number I'm listing here? What's the first cut point I'm going to put there? 0, okay. And it's a closed circle. Now which one is this? This next one, would it be 10 or 21 over 2? 10. Gotta make sure you have them in numerical order. Okay, with the open circle. And then finally 21 over 2 with a closed circle. I want to see you think your way through this. Okay? Imagine me and my brother sitting there, these dumb little ignorant students, trying to think our way through. How the heck do you get these answers thinking your way through? This sequence of steps is great. Now, I cannot use 0 as my test point. Why? Because 0 is a cut point. So if I can't use 0, I'll generally, okay, what about 1? Okay, let's use 1. Or whatever number you want. You can use any number other than 0, 10, or 21 over 2. I remember going to a workshop years ago at a conference about how to make students understand this stuff better, and the presenter's advice was using large test points. Instead of using a 1 to test, we were there doing the problems using 50,437,999.8. It was one of those times I stood up and walked out of the workshop, okay? Using the big numbers doesn't really make it easier. It just ties you down. I'm going to test the number 1. Well, I don't need to ask y'all that. Y'all know where 1 is. It would be right there between 0 and 10. So I'm testing the number 1. Okay. Oops. I replace the z with 1. 1 minus 10, would that be a negative 9? Is greater than or equal to 2 times 1. 2 times 1 is 2. So 1 over negative 9 is greater than or equal to 2. Well, here's how I would think of this. A positive divided by a negative is positive or negative. So we have a negative number is greater than or equal to 2. Well, it's sure not equal to 2. Is a negative number bigger than 2? Can a negative number be bigger than 2 than a positive? What am I trying to get y'all to say this is? True or false? False. False. Okay? A negative number cannot be bigger than 2, a positive number. Negative numbers are always less than positive. So we're saying false there. And you'll fill in the rest of this would be true. This would be false. This would be true. Only if when you're factoring with trial and error, if you wind up with the same thing in both sets of parentheses, where you need to where you need to test all the intervals. Okay, so, oh wait, I messed up. Look at that. I was here thinking, you never have, this one's, what did I do wrong? Okay, so true, false. What should this have been? This should be true. Oh gosh. And false. Well, this one's true here. Okay, once I know this one's false, they alternate. So true, true, and false. Since I messed up like that, I'm going to write it out. True, false, true, false. Oh, wow, this looks bad. I'm going to do that, which I think is probably only going to make it worse. And I'm going to mark out this X. My brother, he's not going to sit there and watch this video. He wants to see a big mess up. So what am I going to have to type in as the answer? I start with parentheses, negative infinity, comma 0, square bracket. in union, what am I going to write? Parentheses, 10, comma, 21 over 2. How am I going to end it? Parentheses or bracket? Bracket. Get that by thinking about it. You think, oh, this is hard. Thinking about it is harder, if not darn near impossible. This. Okay, so parentheses, negative infinity, comma 0, square bracket, union, parentheses, 10, comma 21 over 2, square bracket. If I punch that in, do you think it's going to count it wrong? I'm betting it does. Let's see. Oh, does it know what's going on? No. You see, look, they give you the steps, but on this one they're saying find the values that make our denominator 0. Then solve the related equation. Test a point. Okay, but they don't tell you what's wrong. And what was wrong about it? Right here. I need to get out of that denominator. I'll say right arrow, square bracket. Okay? Notice, don't hit any space keys. Okay? Any questions there? Starting with number 7, I'm not going to do that one, I'm going to do 10. 7, 8, 9, 10, 11, 12, all have absolute values in them. Okay? You might think, oh wow, is that changing anything? Well, the last time we learned how to solve absolute value equations, let me flip through that just to sort of jog your memory. If you've forgotten, remember when we were solving, this was the short assignment the other day. To solve absolute value equations, you need a positive number on the right. If you have a negative number, then that's the no solution. But then you go equal positive, equal negative. That's the name I made up for this, equal positive, equal negative. And you got to always isolate the absolute value bars first. And that's true even now, okay? So when we look at number 10, number 7, it was already isolated. Number 10, oh, I haven't written it down. That's not 11x, is it? Problem number 10. Say absolute value of 1 minus 7x plus 3 is greater than or equal to 8. You might notice this empty set. That would only happen if you got false, false, false for every interval. I've never seen it happen, but it's still listed there as an option, okay? So, let me make sure I didn't miscopy it. Absolute value of 1 minus 7x plus 3 is greater than or equal to 8. Okay. That statement I said, from working with absolute values, always, always, always isolate the absolute value bars first. That still holds. So what am I trying to say you should do on this first? Minus the 3. If you do anything else first, you've messed up. You might get one correct cut point, but you won't get the problem right. So now, isolating the absolute value bars, we have 1 minus 7x is greater than or equal to what? 5? You might be thinking to yourself, oh wow, this, how does this have anything to do with these cut points? Well, is there a less than or greater than symbol in it? If so, then you can use this cut point method to solve it. Okay? If you're a viewing example type of person on this, they make up these little rules that they use to avoid having to draw the number line and test. But those rules fall apart on number 11 and 12. Okay? So why study some rules that'll do a few of them, but not all of them? The cut point method will solve all of them. Since I seem to always ask about denominator cut points first, do we have any denominator cut points? Do we have any denominators? So no denominator cut points. So step one, find those solution cut points. Well, do we know how to solve an absolute value equation? Say yes. You say equals positive. And what am I about to write here? 1 minus 7x equals negative. Remember to solve absolute value equations. If you missed that class on Monday, you have to solve an absolute value equation, you say equal positive, equal negative. Like here on number 4, you'd say equals 6 equals negative 6. Okay. Even if there's a fraction here, equals 9 equals negative 9. Like here on number 5, that was one where we had to isolate the absolute value bars. And so was number 7. And so you're solving the absolute value equation, absolute value of 1 minus 7x equals 5. So that's where I'm going, equals 5 equals negative 5. Now how would I go about isolating the x? I'm going to subtract 1. So I have a negative 7x equals, instead of 4. Are y'all following what I'm doing? With the absolute value ones, you've got to go equal positive, equal negative. Then we divide both sides by negative 7. But we're not going to leave that negative in the bottom. We'll write it as negative 4 over 7. Y'all ready to do the same steps over here? We subtract 1. So we have negative 7x equals, is that a negative 6? And then what? What am I about to do now? Divide by negative 7. So is this one going to be a positive fraction or a negative one?
Positive.
Yeah, positive. We're still doing these cut points. How do we know to do that and not just stop here? If there's a less than, greater than, less than, equal to, or greater than, equal to, you don't stop there. You've got to draw the number line and test the interval. Did I have to factor anything here? No. Will it alternate? Yeah, if there's no factoring involved, it's going to alternate. So draw your number line. Hey, wait, I forgot to ask. Open a closed circle. Close. Since it's a solution cut point, you look at the symbol. If there's an equal sign on the symbol, it's a closed circle. Okay? So close. Let me make a note of that. I'm going to draw. Make sure you put these numbers in numerical order. If you put 6 over 7 right here, you're going to get it wrong. Right? Got to be in the order that you see them on a number line. And a negative number is always to the left of a positive. it's going to alternate. There is no factoring or repeated factors anywhere. So what number am I going to test? Can I test 0? Yes. Like on number 9, I couldn't test 0 because it was a cut point. Okay. But here I can test 0. Where would 0 lie? In the middle, always between a negative and a positive. So this is the interval that I'm going to test. And depending on whether it's true or false, I'll either shade it or cross it out. And then I'll do the opposite to the other ones. Now, when you test, I think it's easier to test with the absolute values isolated. Theoretically, you can use it here, but as a general rule of thumb, once you've isolated the absolute value, I think it's easier just to use this one right here. So let's be careful. I'm plugging a 0 in. Here are my red absolute value bars. I'm plugging a 0 right here. Remember the time I had a student, 69. It took me a while to figure out what the heck he was doing. Okay, let's plug a 0 in, 69. Why is he saying that? And y'all see how he's getting 69? If you put a 0 there, he had 1 minus 70, which was negative 69. Then he took the absolute value of negative 69 and got positive 69. And I was like, wow, you're doing the absolute value and the subtraction right, but this means times. I'm embarrassed by how long it took me to figure out what he was doing wrong. Okay, now it's so obvious. Okay, so 7 times 0 is just 0, so we have a 1 minus 0 on the inside there. It's greater than or equal to 5. 1 minus 0 is 1. The absolute value of 1 is just 1. So we have 1 is greater than or equal to 5. True or false? That's false. Don't help me. Let me see if I can do this correctly without messing up. That means cross this one out. And tell me, am I right? I'm going to shade this one. Yeah, y'all help me so I don't mess up. And I'm going to shade this one over here, right? Okay, good. And now I'm ready to write my interval notation. I'm going to cover up that mess there. So it would be parentheses, negative infinity, comma, negative 4 over 7, parentheses, then a union, another parentheses, 6, comma, wait. Oh gosh, I messed up, didn't I? Oh wow, where is my brain today? I guess I need to think about this some more. That's my problem, okay? What did I do wrong? I said I'll always make the little mark there so I don't mess up and put the wrong symbol. And what did I do? I put the wrong symbol. Close circle, close circle. Sorry about this. Oh, gosh. There. Now I'm going to start all over. And this time y'all better help me or I might mess up again. Parentheses, negative infinity, comma, negative 4 over 7 bracket. Tell me if I'm writing anything wrong. Well, look at this. I even wrote a 6 instead of 6 over 7 there. I really was messing up. Union, bracket, 6 over 7, comma, infinity. There's parentheses. There. Is that what I was supposed to write as the answer? It looks right to me, but it was looking right to me right here when I was writing all this crazy stuff. Okay. Let's see. So I'll type in parentheses, negative infinity, comma, negative 4/7, right arrow to get out of the fraction, the denominator, square bracket, union, bracket 6/7. If you put the parentheses down there in the denominator, it might count it wrong. The parentheses should really be between the 6/7 and the infinity. Any questions there? Notice how we're just sort of building on stuff we did the last time. All of this is building on stuff we've already done. Solving quadratic equations, solving linear equations. I highly, highly, highly encourage you not to, on problems 11 and 12, if you're a view and example type of person, don't do it on this. Just trust me. I'll look at view and example in a moment with you once we're through with this. But problem 11 and 12, you can impress people with this. Okay? People that don't know the cut point method are going to have a very hard time. Let's see. So I guess if I were ruler of the world, the first thing I'd do is make it where they can only use x for variables in equations and stuff, rather than those z's and s's that wind up looking like 2's and 5's. The second thing I would do is pass the law. Well, wait, if I were ruler of the world, I wouldn't have to pass the law. I'd just say it. If you're solving an inequality, you must use this cut point method, as stated right here. That would be my second rule. I can't believe I've never thought of that as one of my rules if I were going to be ruler of the world. So number 11, it has an absolute value. It has absolute values in it. So we're going to have to go equal positive, equal negative? Yes. So x squared plus 7x minus 13 is greater than 5. X squared plus 7x minus 13 is greater than 5. Okay. It's very important that you copy this down correctly because these last two problems, they're rigged to work out with really nice numbers. If I miscopied just a sign, it would make it a much, much messier problem. I'll congratulate the programmer that wrote the coding for this problem because, wow, it works out nice every time. Okay, so it has absolute value bars. Did we, like over here, we had to isolate the absolute value bars. Are these already isolated? Yes. So, are there any denominator cut points? No. So, you're going to solve the absolute value equation. And how do we solve an absolute value equation? What am I going to do? Equals positive 5 and equals negative 5. So, let me see, I'll write it up. X squared plus 7x minus 13 equals positive 5. And x squared plus 7x minus 13 equals negative 5. For solving these absolute value inequalities, if you look at view and example, they're not just saying equal positive, equal negative. They're stating these little rules that you could use that fall apart on this problem. Okay? So, we said equal positive 5, equal negative 5. This is a quadratic equation. So what number do I need here instead of that 5? I need a 0. So let's subtract 5 from both sides. So we have x squared plus 7x. Is that a minus 18? equals 0. What am I going to have to do to solve this for x? Since it's an x squared, I'm going to have to factor this. Is it going to factor pretty nicely? Yeah, it is. We go x and x. 1 times 18, 2 times 9, 3 times 6. Which of those pairs subtract to give us 7? 2 and 9, okay. I say, huh? And you say it even softer. Okay. What's sort of a sign? 2 pluses, 2 minuses, or 1 of each go inside here? 1 of each. Second sign is negative, so how do I arrange them to get a positive 7x? Okay, did y'all hear that? A plus 9 and a minus 2. Now set each one of these factors to 0. And we get x equals positive 2. What's the other cut point going to be?
-9.
Negative 9, good. So far we have 2 cut points. By the way, these are solution cut points, so we're going to use an open or closed circle this time. Open, let's hope I do that correctly here. Making that open circle. Okay, go through the same steps over here, and this is what I'm talking about, who the programmer has it written in such a way, it'll always be something that factors nicely like this. This is really good, solid. If I had majored in math and been a math professor, I think I would have been a computer programmer. Y'all caught up with the x squared plus 7x minus 8? Draw your 2 sets of parentheses. And is it going to factor nicely, or did I lie to you? X and x. 1 times 8 or 2 times 4? 1 and 8. Second sign is minus, so 1 plus 1 minus. How should I arrange it? Minus in the first one here, and a plus there. How many, can y'all see ahead? How many cut points are we going to have here? 4, okay. Setting each one of these to 0, we get x equals 1. And over here, x equals negative 8. So we have 4 cut points. Draw your number line, label all those cut points, decide which interval you're going to test, and test. So let me see. I'm drawing a big number line. Make sure there's 4 of them. 1, 2, 3, 4. I'll label negative infinity there and infinity there. Help me out. What's the order? Which one would be closest to negative infinity? Negative 9, then negative 8, then 1 and 2. There. Since 0 is not a cut point, that's what I'm going to test. But where is 0? Always between negative and positive. It's between the negative 8 and the 1. Again, what are you going to be able to do after this? After taking Mr. Precella's 6-hour-a-week algebra class, you'll be able to locate 0 on a number line. And I'm joking about that. You should be able to do a lot more than that. By the time the semester's over, you'll be impressing yourself with what you can do with logarithms, to say the very least. Okay, so plugging a 0 in for x. The 0 squared is just 0. Wait, I was going to write it in red. That's not a 10, absolute value. 7 times 0 is another 0, minus 13. Be careful before you decide positive or negative. This is sort of tricky, because inside the absolute value bars, we have a negative 13. I'll agree with that. But before you decide between positive or negative, true or false, you actually have to take the absolute value. What's the absolute value of negative 13? Positive 13. 13 is greater than 5. True or false? True. Do y'all see why? Sometimes students will say false because they're just looking at the negative 13. They're forgetting that this is the absolute value of negative 13. So true. This is the last example we're doing today, so hopefully I'm not going to mess up. False. True. Dramatically harder than the other ones we did. It's a little bit more involved. Why? Because of this factoring here. Negative infinity, comma, negative 9, union. Negative 8, comma, 1, union. 2 to infinity. Oh, it was all open circles, so it's just all parentheses. Right on. Type that answer in. Then before we call it quits, I want to look at the viewing example just so y'all can see and appreciate that y'all have something called a cut point method, which makes solving inequalities so much easier than this hocus pocus that they're doing. Parentheses, 1, parentheses, 2, comma, infinity. Number 12 is exactly the, oh wait, we're not finished. Seems that they should have asked this first. Notice how they're drawing the number line. They're not putting open and closed circles. They're putting brackets, which I don't like. But, okay. So these are using closed circles, A and C. So is it B or D? Which one is it? D? Natural question is, why did they do that before? Well, if you look at view an example, and we as teachers, we can turn that off. And every semester I'm thinking, oh gosh, I want to turn this off. But look at what they're doing. How many times, look at that, greater than 22, less than negative 22. It goes on and on and on. At this point, right here, they've factored. They've just done what we were doing right here. Okay? Then, how many times should you draw a number line if you're doing these correctly? Just one. Did we draw a number line, what, with just these two numbers? No, you wait till you find all the cut points. Looking at this craziness they're doing here, they're drawing a number line. And they're testing the intervals right now. It's absolute craziness. At this point, they're finally ready to start right here and do this part. And then they drew another number line. I cannot believe they draw a second number line with just those two cut points. They test. get solutions for that. Then they do, this is the point where I think they start doing their hocus pocus and come up with the final answer. And from the final answer, they then draw the number line. I'm convinced that whoever was doing this knew the answer and was just doing hocus pocus until they got this. I did once follow through this logic, and okay, I can see why this, it's mathematically, it's kind of sound, logically, but this process falls apart if you change this greater than to a less than. With my method, this cut point method, would it have been really any different? Would you have still gone through the same steps if this had been a less than? Yeah. With their method, no. Those steps don't work at all. So I'm always debating turning off the view an example on this assignment, but I didn't. And I remember the semester a student, poor little thing, she was so sweet. She said in such a pathetic little voice, well, how will we know how to do it if you turn off the view an example? And I was like, well, I was kind of sort of assuming that maybe you would do what I'm doing right here, and if you've forgotten, then watch the video. Starting with number 13, I'm reviewing number 12 is exactly the same type of problem as number 11. Starting with number 13, we review that very first stuff we did this semester, the I stuff. So, unless there's any questions that you want recorded, I'm going to stop the recording. And for a long class period,